Hello and welcome. This video is all about routers, specifically routers and templates, and this chest of drawers and one in the next frame are all made using a substructure, and in this following video it explains the strength of this substructure. Check it out.
Hello, so I got this thing assembled, glued, and it feels very strong. Everything's lining up as far as measurements, diagonals. So this thing is about 65, 66 inches. With the top, it'll be almost 6 foot. Pretty big, a lot of drawers, 3, 6, 9, 10, 11. Big drawers, a lot of weight, the contents of the drawers. So what's gonna keep this thing from sagging? Let's think about that for a second. So, in order for this to sag down, that would mean that this 1/2 inch back would have to bend, right? 1/2 inch plywood, veneered both sides, rigid glue. This thing is not going to bend down that direction. It's not taffy. So, there is a possibility that this entire thing could sag this way or move this way, pivoting on that back lower rail, and that would mean that 1/2 inch back would bend this way. That's a possibility. However, with this dude up on top, and then additionally a countertop on top, layers, also rigid glue, in order for this to drift forward by pivoting there and moving forward, and that would mean that all those layers of plywood up at the top would have to bend again laterally. Not going to happen. So it's very strong, right? And of course I just tried to make everything a little bit more lightweight by cutting holes and everything, but based on triangles, this should be very strong and stable. Once it's completely built, I'll put a pair of calipers here, measure that, get up on top, toward the front. I'll stand on top. I weigh about 200 pounds. We'll see if there's any deflection, if at all. If there is, I still have the option of adding a couple of semi-hidden legs right in here. And with that, that'll transfer all the weight from the top, pyramiding down, all the way down to the floor. So, yeah, very strong. I'm super pleased with this. A little bit of an engineering challenge, but I think it's going to work. Anyway, thanks a ton for watching. Enjoy a spectacular day. Ciao.
All right, that was an older video. I just wanted to show you that before I show you this. Now, when I'm routing a lot, I typically like to go outside. It just makes a lot less of a mess. All right, so those are all the parts for the substructure, and you can see pretty clean holes, nice radius inside corners, plenty of room for the drawer guide. That'll actually be like that. Yeah, plenty of room, and it'll just lighten everything up and still will remain very strong. So what I have here is a chest of drawers, well, minus the drawers. Traditionally, with a chest of drawers like this would all have like stick construction, solid pieces of wood to accommodate the runners and to create a substructure to house everything. Well, that's one way to do it, but what I like doing is using full pieces of plywood. And so you can see this one is full piece, as is this bottom one, goes all the way across. And with that, it ties everything together, very solid. It makes a very rigid structure and doesn't allow the piece to twist, especially with a full back, of course. I can lift up on this corner, and even though this is pretty heavy, that other corner just comes up. The piece doesn't twist as it would if this was solid wood construction within the chest of drawers. So yeah, lots of ways to do things, right? And then we can look close. Let me grab the camera. So these pieces of plywood are grooved into the legs, and then there's this additional piece that's strongly attached to this plywood, and then that piece is attached to each leg, front and back, and then also to the side panels. So very strong. And then of course that gives me a place to attach the drawer guides. Then you can see that I kind of cut some of the area out just to lighten up the piece a little bit, weight wise, right? That'll never be seen, and that doesn't really need to be there in these areas. So yeah, lots of ways to do things. This works for me. Live edge, slab, a little bit of sapwood, walnut, beautiful. Ugh. Has this little check. Not sure what that is. Let's see if we can get that fixed. So about a year after I made this table, it developed this little lift, little check. I believe it's where the rings of the tree separated. So here's my solution. Using some 1/4 inch material, I created this upside down wavy V. I assumed that the wavy edges would help hide the line a little bit better. All right, got that cut out and the table. Wanted to show you something, so I'm gonna pull these clamps off. If I needed to put this back exactly where it was, right there, I've got a block here, has sandpaper in the bottom, a sanding block, and I've got that clamped in place and actually a stop here, so this could just literally just go boom, right back. So I'm gonna leave all that until I'm completely done. Of course, if I goofed on the inlay or whatever and I needed to go a little deeper, I would move that block and I could easily just slide this against this dude to, you know, give me another chance to cut another deeper cut. So hope that helps. These router inlay kits are fantastic for something like this. So after making that first cut in the main workpiece, I've got a board clamped, looks like to the tabletop, with that same jig, and I can remove that larger collar off the inlay collar, and I'm going to set the depth using drill bits. I don't remember the exact size. I probably wanted to go about 1/8 inch deep, so I can utilize a drill bit to set that depth. All right, so now I can make this cut, paying attention to router direction, router feed, and then I can slice off that veneer patch at the bandsaw. You may have noticed that those waves are really subtle, because if they're too deep, then as that triangle moves in, the gap would be worse. And keep in mind, the router bit will create a small radius from the router bit in the cavity, in the pocket cut. So that was made sharp with a chisel and a scalpel. I think it's ready for glue, yeah? All right, that's 2 seal coats. I'll let that tack up and shoot the final coat. But that's the inlay there. Inlay / patch. Looks great, right? What seams? Well, there's a seam right through there. There's one right through here. And it appears as though there's some scratches, but I don't remember it showing up in the final product. The customer was super pleased with this and actually gave me a big tip. But you can kind of see the color change there at the tip, but if you didn't know that was there, had I not told you, you would not know that was there. So I have a couple of nightstands, and this component here serves a couple of purposes. It keeps the distance between this panel and this one consistent because it's anchored, and then it's also going to serve as a means of attaching this top. So I need to create a cavity in the bottom of this that is 17.5 by 1.5 inches, and then a certain distance from the front so that this can drop over that. All right, so I have this piece upside down, and I'm wanting a 17.5 by 1.5 inches. Right, so say 17.5, half of that measurement, 3 1/4, half of that would be 1 5/8. We'll just do 1 5/8 in here somewhere. 17.5, I'll just burn 10 inches. 27.5. That should be 1 5/8. Yep. I need to be 1 9/16 back. And then 1.5 inches. Right there is where I want that cavity, right? So let's make a jig. All right, so for my template, it needs to be a little bit wider than this. So I'm gonna add about 6 inches, 7 inches, whatever, right? So this would be for the router base to write on. It needs something. So we'll add about that much. So I'm gonna go about 9 wide, and same thing here. We'll add about 7. So about 24 or 25 wide. So 9 by 25. Ba-boom! Here I've already got one. This is 24.5 by 9. Just some 1/4 inch that got wet. It's kind of warped, but it won't matter. It'll make a good template. It's basically trash, right? And so this was my target dimension of 17.5 wide by long, however you want to look at that, by 1.5 inches. And so here's the combination that I'm going to use. I have a 1/2 inch bit with a 1 inch collar. 1/2 inch and 1 inch. The difference is a 1/2 inch. So basically all I have to do is add a 1/2 inch to that. 17.5 plus a 1/2 inch is 18, right? 18 by, so I have 1.5 inches. I'll add a 1/2 inch to that, 2 inches. That is the template size, or the opening in the template. So we can figure that. I'm gonna go 18 here. Come back this way, that's 6.5, 3.25 here, 3.25 here. That's 18, and that'll give me a 17.5 long cavity. We'll do the same thing by 2 inch. So 2 inches off of 9 is 7. Divide that by 2 is 3.5. 3.5. 3.5. Boom, there's your 2 inches. So it's easy to set up at the table saw. Now these are known as plunge cuts at the table saw, and a lot of people will say that this is dangerous, not to do it. And of course, if you're not comfortable, absolutely do not attempt this. But I've been doing this for a long time, and I find that it is quite safe. So a couple of key points. Make sure that one edge is down tight to the table saw, and the other edge, the adjacent edge, is tight to the fence. If it's twisted at all, then it can grab the board and kick it back. Here my right hand has the board down tight to the table saw. I let it plunge through, make the cut. You can either turn it off or lift it up. And I like the blade raised up a little bit higher than normal. That way the teeth are pushing the board down as it makes the cut. With the blade lower, those teeth are pushing the board back at you. If you plan on lifting the board up, anticipate that and place your thumb or fingers in the miter slots, right? That way you don't have to fumble. So yeah, there are inherent dangers in all machines, and it's up to you to feel safe, be safe, and to make those decisions for yourself. Okay, so typically when I make a jig, I make it plenty long or plenty wide. That way I can clamp. You know, I can't have clamps in the way, but we don't have to use clamps. We can also use screws. And it'll work out great because this template's kind of warped anyway, so I can put a screw over here that probably won't show. Just as long as I'm not in the overhang, I can put one there. I'll put one here. So I use this setup so often that this router bit and the collar were already in here because it's so easy. I love being able to adjust the math by 1/4 inch or by 1/2 inch, however you want to look at that, because of the 1 inch collar and the 1/2 inch bit. Super easy. So now on the depth, of course I've shown this a lot. We're just going to take the router bit, release the handle, drop it down till the router bit just makes contact with the work. Hold that right there, lock the handle. Then we can take the plunge depth rod stop. And I saved a piece of this material which has cherry veneer on one side, 1/2 inch Baltic birch. I don't know what the measurement is, it doesn't really matter. And I can place it right here between the turret and the depth rod. We can lock that in place, and I will be plunging down that distance. Of course, it could be a little bit deeper, wouldn't hurt anything. So I think I'll just allow just a few more thousandths. Something like that. Boom, we're good to go. I really don't even have to make a test cut. I know it's gonna work. But I am gonna take this outside because that's a lot of material and it'll make a mess. So you may be wondering, why not just use a router bit with a bearing up at the top and just make the template the same size as the hole that I need? Well, yeah, you could do that. I am so used to using the 1/4 inch or 1/2 inch offset that this works fine. I can make the plunge cut. I don't have to drill a hole, but as I'm always saying, lots of ways to do things. So when I set up my shop, I intentionally put plenty of power and air outside for situations like this. So now I can literally take this off and I know it's gonna fit. However, if you were doing something like this and you thought you may have to put this back, one thing you can do is clamp a block here, you know, maybe all the way across. Maybe the block has sandpaper on it so it doesn't move, and you can clamp it. You don't have to clamp it so tight because that sandpaper is gonna grip it. And then you could put a mark on it, and that means you'd be able to index this jig right against that block, and you know you'd be right in the same place that you need to be. Or you could put cleats on the bottom of the template, you know, so that you can bring this back into place. Lots of ways to do things. Awesome, right? So my target dimension in the front was 1 9/16 or 1 3/8. Boom, 1 3/8, and then this way, of course, I just need to be centered. 1 3/8, mi scusi, 1 3/8. And you know what's funny? One of the holes is, I can feel it underneath here. One of the screw holes right there. I don't know what I was thinking, that's all overhang, but easy to fix, and I won't say anything if you don't. But yeah, man, that's awesome. Of course, this needs profile. This is going to get a backsplash. And the reason that this dude is on here, what I kind of explained already, but you see this drawer here, there's no style here. It appears as though there's a style, but the style is in fact a drawer front. So you may have noticed that this piece that I anchored down with glue and screws, I had rounded these corners with a 1/4 inch radius, right? Which matches the 1/2 inch diameter router bit, with the intention that I would be doing this. So a little planning ahead. All right, here's another one. So I'm adding one of these wireless chargers. I've got 2 nightstands. I need to make, according to the directions, a 4 1/8 hole. So again, I'm using 1 inch collar, 1/2 inch router bit, right? And I just write it on here, 1/2 inch bit, 1 inch collar. It's a 1/2 inch difference. My target is 4 1/8. I'll just add a 1/2 inch to that. So I need a 4 5/8 template. And I could probably cut this with the Shaper Origin. I don't have a hole saw that's 4 5/8. But you know what? For what this is, I'm just gonna cut this by hand. It'll be good enough. It just needs to be a cavity that will accept this. And I think I can cut it close enough to where it's fairly neat looking. You could use spacers or drill bits to set the depth. And one last one to create a cavity for the cord. You can see that this jig has truly served its purpose. It's been used multiple times. This is for a wireless phone charger, and if the technology ever goes away, well, one could simply unplug it and just leave it in place. So here I'm going to be using a router inlay kit, and I went into it a little bit more in depth in another video called Drawer Box Inlay. I'll leave a link in the description. Using 1/4 inch MDF, I made a simple jig by just making it into 3 separate pieces and adhering it all together with some cyanocrylate. We'll hold that down with some double stick tape, and then we can create the cavity. I have this collar marked with red so I don't get it mixed up with my other collars, and you can see this outer ring that slips over the primary collar to make the cavity cut. Setting the depth is straightforward. Bring the router bit till it makes contact with the work. Then I can take a piece of the material, same thickness as the inlay, well, it's the actual inlay material, set it between the turret and the plunge rod depth stop, and boom, we are set to go that deep. Now I believe in the other video that I mentioned, I used another router with a larger bit to hog out all of that interior or pocket cut. We'll pop this dude loose, being careful not to break it. And of course, we'll utilize the same jig to make the insert piece or the inlay part, right? And I like using a scrap piece of lightweight MDF as my wasteboard. And now we can remove that outer ring. And again, we'll check the depth. And I want to go just slightly deeper. That way the inlay part is slightly thicker than the surrounding material. This makes sense to me because this way you're removing inlay material, not surrounding material, to get things flushed up. In hindsight, I should have had a piece of tape where the inlay got cut. That way it doesn't, rattle around after the router cuts through it. All right, at this point you can see that if you wanted sharp corners, you could just square these up or sharpen these round corners with a chisel or utility knife, scalpel, however you want to do that. Or you could choose to radius these corners to match those. A couple of different options. All right, so I went ahead and slightly back beveled these edges, just very slight. Went ahead and sharpened the corners, and decent fit. It's not great. These do okay. One thing that will help is when you are cutting your cavity. Lost my little washer. There it is. So when you're cutting your cavity and this piece is on there, one thing that you can do is wrap this with maybe 1 or 2 layers of tape, and that'll make a smaller cavity and it'll make a better fit. I've done that in the past because sometimes these fit really well and sometimes there's a slight gap. So by wrapping that with tape, you'll make a tighter fit. Incidentally, you can take this same principle, check this out. If you have a really large inlay, maybe in a floor or something, you can take the same principle and extrapolate that math to accomplish the same thing. So I've got a 1/2 inch bit, 1 inch collar, and a 2 inch, this is actually a bearing, but it has a 1 inch ID hole, and this would slip over that collar and accomplish the same thing, just on a much larger scale. Of course, this one is 1/8 inch bit, 1/4 inch collar, and then overall this is a 1/2 inch. But this wall thickness is what counts for, well, as related to the diameter of the bit. So this is an 1/8 inch wall thickness, 1/8 inch bit. Same thing here, 1/2 inch wall thickness, 1/2 inch router bit. Well, that's it for this video. I certainly hope you got something out of it. Remember, click like, subscribe, learn.